Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we're talking about using derivatives to find slope. Hey, jealousy. Other folks are jealous because they will not be able to use derivatives to find slope. And what we're finding the slope of is the tangent line drawn to the curve. So if we were to graph f of x equals x squared and draw a tangent line where x equals 1, what we're going to be able to do here is find the slope of that tangent line. Very simple, very easy. Okay, so recall, first of all, recall, that rhymed, that was awesome. Recall, okay, if f of x equals x to the n, then the derivative, f prime of x, is equal to n times x to the n minus 1. And furthermore, if there is an a there, it's n times ax to the n minus 1. Okay, so let's move over here. We have f of x equals x squared. So f prime of x is going to be equal to 2 times x. Remember, there's a 1 there, so it's really 2 times 1. We just don't write it. To the 2 minus 1. So the derivative finally is equal to 2x. Yes, because 2 minus 1 is 1, so 2 times x. So we want to find the slope of f of x at x equals 1. Well, the derivative gives us the slope of the tangent to the curve, or the gradient. Slope and gradient, same thing. So what we're going to do is replace x with 1, because that's the point that we're interested in. That's what we're talking about. So f prime of 1 is equal to 2 times 1, which is equal to 2. Okay? So the slope of the graph of y equals x squared at x equals 1 is equal to 2. And let me show you what I mean. I graphed it for us. Here is the curve, f of x equals x squared in blue. And then I drew the tangent line on the curve right here. Here's our tangent line right there. And then I plotted the point where for x equal to 1 right there. Okay, now on the function, when x equals 1, y equals 1, because 1 squared equals 1. But then I asked the calculator to find the slope of the tangent line. Well, the slope of the tangent line at this point, when x equals 1, is 2. And just so you believe me, I can drag it, and you can see how the slope changes. It's going to go to 0 there when it's horizontal. Then it's negative, right? But if I go back to when x equals 1, the slope of the tangent line is indeed 2, which is exactly what we found right here. We did it using calculus. A little bit of algebra and some calculus. Okay, let's try another one, only 2 more, including this one. So we're going to say that y prime is equal to 2 times 3 times x to the 2 minus 1. Yes. Okay, move the exponent in front. Minus, there's a 1 here, up here right there in the exponents. That's 1 times 4, this 4 right here, x to the 1 minus 1. And then the derivative of any constant, a constant is a number just by itself. It's not associated with a variable. So the derivative of 8 is equal to 0. Okay, so let's clean this up. So y prime is equal to 2 times 3 is 6, x, because 2 minus 1 is 1, minus 1 times 4 is 4, times x to the 0 power, right? Well, guess what? X to the 0 power is equal to 1. Anything to the 0 power is equal to 1, so y prime equals 6x minus 4 times 1, or 4. Okay? But we are charged with finding the slope of the tangent to this curve right here when x equals negative 2. So now we just find y prime of negative 2, meaning we just take x and we replace it with negative 2. So this would be 6 times negative 2 minus 4. So that would be negative 12 minus 4. And so what we have found is the slope of the tangent to the curve, 3x squared minus 4x plus 8, when x is negative 2, is negative 16. And I've graphed that for you as well. Okay, we got the curve, see, 3x squared minus 4x minus 8. I have the tangent line right here, right there, and I've let x equals negative 2. You see that? And then I asked to measure the slope of the tangent. Remember now, this 28 is just the y value when x is negative 2. In other words, if we replace x with negative 2 in the original function, then its value would be 28. But I'm interested in the slope of the tangent to the curve when x equals negative 2. And I asked the calculator to measure it, and it is indeed negative 16, which I believe, let's double check. Yep, that's what we got. And again, just so you believe me, I'll go ahead and move this tangent line around, and you can see how the slope is changing, right? The slope of the line is changing. But when I go back to negative 2, the slope is negative 16, just like we found. Okay. All right, last example coming up. It's a bit of a funky one. Okay, so y equals x to the fourth minus 3x cubed plus x squared minus x over x squared at x equals 3. Well, I need to take the derivative, but I need to simplify this first. This is equivalent to x to the fourth over x squared minus, right here, 3x cubed over x squared. We're going to divide each term by x squared here, plus, ooh, good news, x squared over x squared minus x over x squared. All right, so, oops, that's a horrible 2. X squared. All right, so y becomes x to the fourth over x squared. I subtract the exponents. 4 minus 2 is 2, so this becomes x squared minus, nothing's going to happen to this coefficient, minus 3. X cubed over x squared, 3 minus 2 is 1, so this is minus 3. I wrote a bad 3, didn't I? 3 x to the first power, which I'm not going to write the 1 there, plus x squared over x squared, same thing over same thing, that's equal to 1, minus, now you got to be a little careful here, remember this is x to the first power, and 1 minus 2 is negative 1, so this is minus x to the negative 1. Okay? Now, this is still this same expression, I just simplified it a little bit. So now I need to take the derivative, or find the derivative. Y prime is going to be equal to, I'm not going to do it step by step this time, 2 out in front, x to the 2 minus 1 is 1, which I'm not going to write. There's a 1 here. 1 times negative 3 is negative 3. 1 minus 1 is 0, and x to the 0 is 1, so this would be negative 3 times 1. The derivative of any constant is 0. Okay, we got to be careful here. So we have this minus here. Now I have a negative 1 that I have to bring out in front, right? You take the exponent and put it in front, times x, and to the negative 1 minus 1 is negative 2. So let's clean this up. Y prime equals 2x minus 3 plus 0 is still minus 3. This becomes plus x to the negative 2, and I'm going to go up here because I'm running out of room, and I'm going to rewrite this because I know if I just ask for the derivative, this would be fine, but I need to evaluate it. So I'm going to rewrite it in a more friendly way with this negative exponent because we're not quite sure how to deal with that maybe. So y prime equals 2x minus 3 plus, and remember I can write that as 1 over x squared. It's in the numerator now. You can think of this as over 1 if that confuses you. And to make this exponent positive, I move it to the denominator like I did here, and the exponent becomes positive. And there's still 1 in the numerator. So now I need to find y prime of 3. Easy peasy pumpkin pie. So that would be 2 times 3 minus 3 plus 1 over 3 squared. Wherever I see an x, I replace it with a 3. So this is 6 minus 3 plus 1 over 9. Okay, and so 6 minus 3 is 3, so that's 3 plus 1 over 9, which is 3 and 1/9, which is actually equal to, in decimal form, 3.11 forever and ever. The ones repeat forever. So what we're claiming, that's a horrible 3, is that the slope of the tangent to this curve, this awesome curve, when x equals 3, we're claiming is 3.1111 repeat. So again, let's take a look at the last graph that I did for you. Oops, wrong thing. Right here. And I graphed it in blue. So that is the original function. Constructed a tangent line. Let x equals 3. Asked it to find the slope. Oh, I don't have it real nice. I'll put it under here. And it is indeed 3.11 because it's only going to do 2 decimal places. And again, just to convince you, I'll move it. Ooh, that was kind of cool, wasn't it? Okay. And then I'll put it back to 3, and again, it's 3.11. So that is all. Hope you enjoyed it. I certainly did. We'll go and see how the Gin Blossoms are doing here to finish it up. And I am out!